The second example for section 7.1 falls around a rational function of exponential pieces. So this is dx divided by e to the x plus e to the negative x. Looking at this immediately, your first attempt is considering that it's a rational function. Let us let u equal to the denominator. However, in doing so, we end up with this du being e to the x, plus a negative e to the negative x dx. And you'll notice that we're missing this whole bottom piece, and given that this whole bottom piece here is a function, it can't be put in here in any way. So this u substitution apparently doesn't work for us, not efficiently anyway. So our next step is to try and manipulate this algebraically, and the way that we're going to see this most efficiently is by first shifting that dx off to the side. This allows us to visualize this thing as just a function, and then therefore we have a dx sitting outside and a singular function. Now, the second piece you're going to want to notice is this is e to the negative x, and e to the negative x in algebraic sense is actually just another fraction. So this is actually 1 over e to the x plus 1 over e to the x dx, and this is the problem that we have here. This is a fraction of a fraction. In having this, it causes problems with the overall algebra that we're going to have to do. So the real step in terms of simplifying this and making it easier for us to deal with is by eliminating that secondary fraction, and in doing so we're just simply going to go ahead and multiply the top and the bottom of the large fraction by the denominator of this interior fraction. So we're going to have e to the x multiplied to the top, and then we're going to have e to the x multiplied to the denominator. This will provide us with e to the x on top, and on the bottom e to the x, and I'm going to go ahead and write it as x squared in that form, and then plus 1 dx. Now you could try and visualize this e to the x squared as though it's e to the 2x because it's power to a power and you can multiply those powers. However, this thing is not as efficient for us to work with in this example. Again, there are multiple different ways you can attempt to view these problems, and you might want to have to play with the algebra that you're looking at to get to a problem that will actually, an example that will actually work for us. So with this being done, I'm going to go ahead and look at this as though, u is equal to e to the x. That is the interior of this bottom piece squared. Not the whole thing in the denominator, because if we try that, you'll notice it's going to be e to the x2 to the second power, and when you try and take the derivative of that, there's going to be a really nasty algebraic information that you're going to have to do. So what I'm going to stick with is just e to the x. Therefore, my du is going to also be e to the x dx. And you'll notice the e to the x with that dx become absorbed and then become my du, where the bottom is just going to be u to the power of 2 plus 1. So after we do this u substitution, we're going to end up with the integral of 1 divided by u squared plus 1 du. Again, the e to the x and the dx get absorbed by du, so there's a 1 on top still, and then my ex becomes u squared plus 1. So now if you're looking at this, hopefully again you've reviewed those basic integration formulas from page 503, because this right here is just your arctan integral. Therefore, this integrates into tan inverse of u plus c. Okay, or again, the other way you can write it is arctan of u plus c. Please do not confuse this negative one as though it's the same thing as 1 over tangent of u. That is not what that is. It is absolutely wrong if you write it that way. This is tangent inverse. It is a very different function than the rational of 1 over tangent. We have a name for that function right there. That's cotangent. So this right here is almost where we're done. The problem is again, we still have a u in here, and we started the original problem with an x. So to finish this problem off, we will simply back substitute and therefore end up with arctan of e to the x plus c. Again, notice I did the algebra to get to something that I could integrate with a u sub and then integrate it. And then don't forget to back sub. That right there is the end of that problem.